Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today's topic is problem number 4 based on the Laplace transform of elementary signals. Now, in today's example, my question is, it consists of two ramp wave having positive slope and negative slope, and after that it is a combination of two slopes plus one state signal or a square signal. So first of all, just go through that question. Now look at here. This function x of t is having or is carrying two slopes. First one is increasing positively, second one is decreasing, and next one is a simple square wave. Now what we have to do, we have to find out a Laplace transform of this first question. Before solving this question, you should know how to write the equation of given question. And if you know that, then you can easily find out the Laplace transform of given question. Now first important one is, we have a combination of two ramp wave and then one square wave. So in case of ramp wave, you should know the basic formula of that signal, which is a slope into time t. Now if your slope is increasing positively, then of course the value of slope will be positive. If your slope is decreasing negatively, then the slope value is negative. And then next one is a square wave. So we'll try to solve the equation. We'll write equation first and then we'll go for the solution. Now look at here. In this question, as I told you earlier, it consists of two slopes or two ramp wave and one simple square wave. So first of all, I'm going to write the equation for this x of t. Now first of all, x of t. As I told you earlier, it consists of a two ramp wave. The first of all, try to calculate the slope of that ramp. So you have studied the formula to calculate or to find out the slope. That formula is m is equals to y2 minus y1 upon x2 minus x1, where is the y2 is the next value and y1 is the initial value, and x similarly with the x2 and x1. This x value varies with respect to time, whereas this y value varies with respect to y-axis, or you can say amplitude axis. Now look at here, in the first slot, that is from 0 to 1. Now whenever you want to write down the equation, just do one thing. Just check where your graph changes its value. Now in 0 to 1, the graph is increasing positively, but from 1 to 2, it continuously goes on decreasing. And in between 2 to 3, you have a simple square wave. So means what? This x of t can be written in three different formats, or you can say in three different parts. The first part is available in between 0 to 1. The next is available in between 1 to 2. And the third part is available in between 2 to 3. Now, what we are going to do? We are going to find out the value of x of t in between these three regions. So first of all, we'll calculate the value of a slope in between 0 to 1. Now look at here. The slope formula I have written, which is y2 minus y1 upon x2 minus x1, whereas y2 varies in vertical manner, whereas x value varies in horizontal manner. Now look at here. x1 is initial value, whereas x2 is the final value. Similarly, the y1 is the initial value, whereas y2 is a final value. Now first of all, we'll calculate the x1 or x and x2. Look at here, in between 0 to 1, I will write down the first of all the time period. In between 0 to 1. Now first of all, your graph is started at 0, means what? Your x1 value is 0. So I will write x1 value 0 first, and then x2 values, your graph is changing its value in between 0 to 1. Means what? Your x2 value is 1. Now we'll move on to y, that is amplitude part. Now initially the amplitude of this slope is 0, so y1 value is 0, whereas in case of y2, this slope is increasing up to 1 and then it goes on decreasing, and I'm calculating this value in between 0 to 1, that is in between this region. We have to find out the amplitude, that is highest value of y, and that place will be a y2. So your graph is increasing. It started from 0. That place or that amplitude is y1 and it varies up to 1, which means your y2 value is 1. So I'm going to write here 1. Now just perform the subtraction. What you will get? 1 minus 0, 1 minus 0 is 1 and 1 by 1 is answer is 1. So you can say that the slope of this first ramp wave, that is which is available in between 0 to 1 is 1. Now how you are going to write the formula of a ramp wave? The ramp wave formula is always m into t, means what? Your slope value is 1. So I am going to write 1 into t. Next, we'll calculate the value for slope which is available in between 1 to 2. So here I am going to write, again we will find out the slope value. Now the formula is same, y2 minus y1 upon x2 minus x1. Now look at here, in this graph, your last value is over here for y1 and the next value of y2 is over here. Means what? y1 value is 1. Just look at this formula. y1 value is written after minus 1 sign and y2 value, this graph is reaching at 0, means your y2 or the amplitude at 2 is 0. Similarly, move on to next step. Now here your time period varies from 1 to 2. Which means your 1 is the x1 whereas x2 is 2. So I'm going to write 2 first and x1 is 1. Just perform this subtraction. 0 minus 1 is minus 1 and 2 minus 1 is 1. The answer is minus 1, which means your slope value is minus 1. So how we are going to fill this formula? Just multiply t by minus 1. What you will get? Minus of t. Now in third case, in 2 to 3, look at here, in 2 to 3 you have one square wave or simple a square pulse which is having a constant amplitude and it is 1. So I am going to write only amplitude 1 in between 2 to 3. And now once you got this information, then just apply Laplace transform on x of t, where x of t's value is t in between 0 to 1. X of t value is minus t in between 1 to 2 and x of t value is 1 in between 2 to 3. These are the values of integration limits. This one is the lower value, this one is upper value for t, or you can say x of t. In first case. In second case, the x of t value is minus 2, where the integration limit lower value is 1, upper value is 2. And in third case, x of t value is 1, whereas the integration limit is 2, that is lower value is 2 and upper value is 3. Now, we will apply a Laplace transform on given question. So, let's see what is the next procedure. So first of all, we will apply the definition of Laplace transform. According to definition of Laplace transform, what we can say? A Laplace transform of any time signal is represented by Lx of t. Or you can say a Laplace transform of x of t, and it is represented in a s domain, or you can say a frequency domain by x of s. And the definition is minus infinity to infinity x of t into e to the power minus st dt. Now the next one, first of all, as I told you earlier, your x of t is divided into 3 parts. So this integration will be also divided into 3 parts. So let's see what will be the value of x of t, and we have studied that value of x of t and for different types of intervals. So we'll substitute that value with that given interval that I have mentioned earlier. So the values of x of t in between 0 to 1 is t, whereas in between 1 to 2 it is minus t, and in between 2 to 3 we have, like in question it is, there is one square wave and the amplitude is constant, which is 1. So I have written over here. Now these are the values of x of t which is multiplied e to the power minus st. That's why I have multiplied it by e to the power minus st, and all this product is integrated with respect to time t. That's why I have written dt at the end. Now the next step is, we have studied one formula, Liet formula, which is used in integration. According to Liet, this t is the algebraic whereas e is the exponential. So using Liet formula, this t is my u whereas this e or exponential part is my v. And we know that we have studied this formula in previous case also. So we will use that formula to solve this next integration terms. Now, according to the formula of u into v, integration of u into v, what you can say? What you are going to write? Integration of u into v. Let's say with respect to dt we are going to integrate. So the formula is u integration of v, that integration is with respect to time t, minus integration derivative of u, which is this u is differentiated with respect to t, again integration of v, and this is the formula of u into v, integration of u into v. Now we will use the same concept. So first of all, our x of s, I am going to write x of s value once again so that you can understand the values of u and v in each and every case of integration. So first of all, let me write first. So now look at here. In first part of integration, as I told you earlier, in both the parts you can say the t in first and second part, t is my u whereas v is my exponential part. So according to formula, I am going to place all the values in this formula. So first of all, u I have to keep outside the integration term, so t will be outside, and integration of e to the power minus st with respect to time t, because we are integrating all the terms with respect to time t, minus integration of d by dt of u, where my u is t. So here I am going to write d by dt of t. Again we are going to integrate this v, where my v is this. This is my u, this is my v, this is my u, this is my v. And in next part we have only e to the power minus st, so there is no use to apply Liet formula. Now look at here. Now v is my e to the power minus st, so I am going to write here e to the power minus st dt. This is the formula for first bracket, and I am going to write the integration limits. Now I will take minus sign outside so that this term will get minus sign first. Now again use the same concept, where my t is my u and e to the power minus st is my v. So we will write t integration of e to the power minus st minus integration of, you can say directly, you can copy this term as it is because only the minus sign is the different, but do not write these two terms or these two products are same, but much more important is integration limits are different. So please do not equate these two terms because the integration limits are different. And now the last part is integration of e to the power minus st dt, and the integration of e to the power minus st with respect to time t, as I told you earlier also in previous videos also, integration of exponential wave is, or exponential term is always just divide this whole exponential term by its amplitude having some constant part. Just divide e to the power minus st by its constant part which is present in its power. Now here the constant part, how to identify constant part? Basically we are integrating this term with respect to time t, so t is my variable and the terms which is present or present in the product form with a t is my constant term. So simply just divide a constant term which is present in the power of exponential term with its sign. So e to the power minus st upon minus s is my answer of integration, and I have written intervals of that integration. Now we will apply the integration inside this formula. So in first block what we have, t into integration of e to the power minus st is e to the power minus st upon minus s minus of integration of d by dt of t, which is 1. So I have written 1 over here, and the integration of e to the power minus st is e to the power minus st upon minus s. But again this term is going to be integrated, that's why I am going to write here dt, and the interval limit is 0 to 1 minus, just note down all these things once again, which is t into e to the power minus st upon minus s, minus of integration. Again there is a t present in second integration, so the differentiation of t with respect to time t is 1, and this e to the power minus t was also there, which is integrated once again, and the integration of that value is minus s, and this is the integration that we are going to apply once again. And the next part, which was e to the power minus st upon s, the limit is 2 to 3, and the limit of this value is 1 to 2. Now again integrate this part. What you will get? E to the power minus the integration of e to the power minus st is again minus s. So you can say that minus s we have already there, and after integrating this term we will get one more minus s. So you can say that minus s into minus s become plus s square. So this sign will not be changed. So in both the terms over here and over here, I am going to write e to the power minus st upon whole s square. So look at here. I'll take this minus sign in the numerator, minus t e to the power minus st upon s minus e to the power minus st upon s square. This is my first part integration, minus second part. Again I'll take minus sign in the numerator, and the third part of this integration is, now here just substitute the values of upper limit and lower limit. So what you will get? E to the power upper limit is 3, where we are going to substitute this limit value in the place of t, because we integrated whole function with respect to time t. So whenever you want to substitute limit value, then always replace that t value by given or mention time intervals. So upper limit will be substituted first and then lower limit, but in between upper limit and lower limit we have to place a minus sign, don't forget. So upper limit is 3, so I'll replace this t by 3. What you will get? E to the power minus 3s. Now as I told you, just place minus sign in between upper limit and lower limit terms. The lower limit is substituted over here, so this will be e to the power minus 2s whole divided by minus s. Now we will substitute the values of upper limit and lower limit in given formulas or given equation. So first of all we will substitute upper limit in this part and minus sign will place, and then I will substitute lower limit in each and every part of first bracket. So what you will get? This t is replaced by, all this t is replaced by 1. So what you have? Minus e to the power minus s upon s minus e to the power minus s upon s square. This was my first term. Now I will substitute the lower limit. Lower limit is 0. So simply replace this t by 0. What you can see? If t value is 0, then whole product becomes 0, and 0 upon anything is always 0. So I will place first term is 0. Whereas next part, if this t value is 0, then the whole power becomes 0, and e to the power 0 is always 1. So I am going to write here 1 upon s square minus. Now we will do the same thing in next block. Look at here. In first part, first of all, we will substitute the upper limit, which is 2. Now all this t will be replaced by 2. So what you will get? Minus 2 e to the power minus 2s minus, which is this sign, e to the power minus 2s, and in denominator we have s and s square. Now I'll substitute the lower limit over here. Bracket is not yet completed. Now lower limit is 1, so we'll replace all this t by 1. So what you will get? Minus of e to the power minus s upon s, and the next bracket I'll take minus sign in the numerator. So now basically I have substituted all the values in earlier part. Now, as well as I have arranged the terms by taking or by multiplying minus sign inside this bracket, and what I get is minus of e to the power minus s upon s minus of e to the power minus s upon s square plus 1 upon s square, and in second integration bracket we have minus of 2 e to the power minus 2s upon s minus of e to the power minus 2s upon s square plus 1 bar plus e to the power minus s upon s plus e to the power minus s upon s square, and the third bracket which is already we have solved. Now what I'm going to do, I'm going to take s square common in all the brackets. Now how will take s square common in the denominator? Just simply multiply and divide it s to those terms where in denominator we have a single s. So look at it. In first part we need to multiply and divide it by s, so that denominator part become s square, and as the all the denominator part become similar, then you can add numerators at a time. So now in first part over here and over here I'm going to multiply and divide s. So first of all, minus of s into the power minus s minus this term will be written as it is, because in the denominator we have a s square, a plus 1. Now next part minus here in these two terms we have to multiply s and s in the numerator and denominator. So what you will get, minus of 2s e to the power minus 2s minus e to the power minus 2s plus e to the power minus s into s, because this term we have to multiply it by s, and plus e to the power minus s and whole divided by s square. And third part, in both the parts I'm going to multiply s as well as in denominator also. So s into e to the power minus 2s minus s into e to the power minus 3s whole divided by s square. Now in next part what I'm going to do, I'm going to equate all the numerators, and because the denominator of each and every bracket is s square. So let's see the next part. Now what I have done, I have equated all the brackets, I have multiplied minus sign inside the bracket, and this is the equation right now I have. Now just try to find out the similar terms so that we can take a common, or we can add, or you can say we can cancel those terms. So first of all, look at here, we'll find out by using e to the power minus s. Here we have minus s e to the power minus s. Now just in this whole part here also we have minus s e to the power minus s, and in next part we don't have such type of terms. So how many terms we have? This is first and this is second. So I'm going to write here minus 2s e to the power minus s. Now we will find out only e to the power minus s term. Here we have e to the power minus s only. Next over here we have e to the power minus s. So I'll write minus and minus, so this will be minus twice of e to the power minus s. Now we have a constant term here 1. Now in whole equation only one term is there, which is 1. How many parts we have solved? This part, and this part, and this part. Now what about next? This part is also solved. Now twice of s e to the power minus s we have, we'll find out. Twice of s e to the power minus s. Look at here. Only e to the power minus s we have. No, it is not there. So we'll write plus twice of s e to the power minus s. Now next, so this part is also done. Now plus e to the power minus 2. Here we have e to the power minus 2s. Fine. So we have only 1 e to the power minus 2s. Similarly, just move on to next. So these are the two terms left. I'm going to write it one as it is, s e to the power minus 2s minus s e to the power minus 3s and whole divided by s square. Now look at here. Can I say that minus 2s e to the power minus s and plus 2s e to the power minus s will get cancelled? Of course, yes. So you can say that these two terms will get cancelled. Now next one, twice of e to the power minus s is not there. So I'm going to write here, I'll write first 1. It is not necessary, but still I'm writing minus of 2 e to the power minus s. Next, this part is done, this part is done. What is left? These two parts get cancelled actually. Now these three parts is remaining, so I'm going to write this remaining part as it is, e to the power minus 2s plus s e to the power minus 2s minus s e to the power minus 3s and whole divided by s square. So this is how you are going to find out a Laplace transform of that part. So it is easy to find out. First of all, what is important? The important thing is, first one, you should know how to write the equation of given graph. Second, you should know the different formulas related to integration. And once you know all the stuffs, then you can easily obtain the result, or will get the result of given graph. So thank you for watching this video. Stay tuned with Ekeeda and subscribe Ekeeda for further more videos. Thank you so much.